Hi there, my name is Curtly Johnson and I'll be taking you through another math fundamental. I'll be taking you through Unit Standard 7480, NQF Level 2, 3 credits. The Unit Standard title is Demonstrate Understanding of Rational and Irrational Numbers and Number Systems. Our first topic is number signs and calculations. So now let's look at the concept of BODMAS. So BODMAS is an acronym. The B is brackets. Calculate the brackets first. O is of. Do all the operations with the word of in it. D is for division. Do all calculations that require division. M is multiplication. Do all the multiplication calculations. A is addition. Do all the addition calculations. And finally, subtraction. Complete the subtraction calculations. So guys, when we deal with BODMAS, we deal with the B first because it's at the top. Brackets, then we deal with O, of, then we deal with D, division, and so on. So let's take a look at some examples. That means we go to the blackboard. Our first example is 10 of 3. What does this mean? O first, remember. Of simply means times. So 10 times 3 is 30. So our next example says 10 times 3 minus 15. As a reminder, let's look at the BODMAS acronym. Brackets, of, division, multiplication, addition, subtraction. What do we have? We have multiplication, we have subtraction. Where are they? Multiplication's over here, so that gets done first. Then we have subtraction, that gets done next. 10 times 3 give you 30. Then subtraction, and that will give you 15. This brings us to our next example. 10 minus 5 divided by 5. Keep in mind the 10 and the 5 is in brackets. What does BODMAS tell us? B first, brackets first, then division. Let's do the brackets first. 10 minus 5 is equal to 5. Divided by 5, which will equal to 1. It's as easy as that. And our final example is 50 plus 5 times by 2. Guys, remember, when we have two different signs in our sum, we always go back to the BODMAS. So, 5 times by 2 gets done first because it's a multiplication. Next, we have addition. So let's do the multiplication first. 5 times 2 is 10 plus 50. That will give us 60. Our next topic, estimating to the nearest whole number. For example, I am estimating that from here to here is about a meter. Am I correct? Maybe not, but I'm estimating. So now let's look at the formal definition of the word estimation. It helps us find the closest possible answer without doing an actual calculation. So guys, in my opinion, this is all just a form of simplification. So let's look at the two simple rules that apply. Number 1, when the first decimal is bigger or equal to 5, we round up. Number 2, when the first decimal is smaller than 5, we round down. So let's look at 4 examples of how to estimate to the nearest whole number. Whole number. So we are hoping to estimate this number, so we focus to the number on its right, which is in actual fact the first decimal. Because our first decimal is less than 5, we round it down to 5. Now let's look at the second example. We're trying to estimate the number 7 less than 5. Therefore, we round it down to 7. Now let's look at this number, 65. We are looking for the nearest whole number. So we're focusing on the 5, which means this number is equal to 5. Remember rule number 1, guys. Therefore, we round this one up to 66. And in our final example, guys, you'll be familiar with this now. Number 4 is our focus. Therefore, we look at number 6, larger than 5. Therefore, we round up to 5. So this brings us to a little bit more of a complex topic, fractions and simplification. To simplify a fraction, we use the greatest common factor, the GCF, to determine a fraction in its simplest form. So what does this mean for us? Let's start at the beginning. Let's take a simple fraction, 4 over 10. So the 4 is the numerator. And the 10 is the denominator. Remember, in the definition, we need to find the GCF, the greatest common factor. But our first step will be to find the factors. So the factors of 4 is 1, 2, 4. The factors of 10 is 1, 2, 5, 10. The common factors are 1, 2. So therefore, the greatest common factor would be the largest common factor, 2. So let's divide this by 2. That will be 4 divided by 2 will be 2. 10 divided by 2 will be 5. That is our fraction in its simplest form. So here's another example of fractions and simplification. 20 over 120. Now these are big numbers. When zeros are involved, we can simplify it by scratching out the zeros. Now we are left with 2 over 12. But this is not its simplest form. The factors of 2 are 1, 2. The factors of 12 are 1, 2, 3, 4, 6, 12. But we did not need to go this far. As we can see, our greatest common factor is 2. So we divide them by 2. 2 divided by 2 is 1. 12 divided by 2 is 6. That is our fraction in its simplest form. Our next topic, working with percentages. It is very, very essential for you to understand how to work with percentages. So our aim in this topic is to convert a normal number into its percentage form. But how do I do that? Let's take an example. A glass. This glass is half full. Now we all know this is 50%. But why? Keep in mind, a percentage is always out of 100. So if I say 60% of something, that will equal to 60 over 100. So if the something was 80, we multiply the something with the percentage. So 80 times by the percentage, which is 60 over 100, give us 48. So to conclude, 60% of 80 is equal to 48. So let's look at an example of how to convert a fraction to its percentage form. Let's look at the number 3 over 4. In order to convert a normal fraction into a percentage, we need to times it by 100. Punch this into your calculator. 3 divided by 4 times 100 will give you 75. 75 what? Percent. So that's example number 1. Let's look at another example. 7 over 8. Remember, times by 100. Punch that into your calculator. 7 divided by 8 times 100 will give you 87.5%. So imagine you wrote a test. You just received your results. You received 40 out of 55. Now, what is your percentage? What have you actually received? Let's do the math. 40 over 55 in its percentage form would be 72.72%. A percentage question can be asked in different ways. For instance, 30% of 50. Now remember, BODMAS states that of is a times. So 30% is 30 over 100 times by 50. Punch this into your calculator. 30 divided by 100 times by 50 will give you 15. Another random example might be 2 over 10 of 70. Now remember, BODMAS, of is times. 2 over 10 times by 70 in your calculator is 14. That is your answer. So in our final example, if half of our cupcake is 30 grams, how heavy is the whole cupcake? Let's draw this out. Here's our cupcake. Half of it is 30 grams. How heavy is the whole thing? Remember, half is 50%. We are looking for 100%. So we times the 30 by 2. That will give us 60 grams. Therefore, our whole cupcake is equal to 60 grams. Now we are at the topic of scientific notation, which is a way to simplify either really big numbers or really small numbers. Let's take a look at some examples. Let's take the number 2 billion and simplify it using scientific notation. 2 billion, many zeros. So in scientific notation, we would count from right to left. How many zeros do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 zeros. So let's take the first unit, or all the numbers before the 0. This could be 21, 22, but in this case we have a 2. Times 10 to the power of how many zeros we had? 9. And that is 2 billion in its simplest form of scientific notation. On the other side of the scale, we could have very small numbers. less than 1. Let's take a look at this example. So that was example number 1. Example number 2. 2 times by 10 to the power of negative 5. Don't let this negative 5 scare you. Write your 2 on the right side. Remember, we are counting. Negative 5, 1, 2, 3, 4, 5. 0.1, 2, 3, 4. And that is our answer. 0.0002. Now, let's convert a very small number to scientific notation. Example, 0.00075. So this will be 7.5 times by 1, 2, 3, 4, 10 to the power of negative 4. Our next topic is simplifying variables. So what is a variable? A variable could be A for apple, B for banana, and C for carrots. They cannot be added together, they cannot be subtracted, they cannot be divided, but it can be simplified. When a number is put in front of a variable, it tells you how many variables there are. So 2B could represent 2 bananas. Similarly, 3C could represent 3 carrots. Let's say we are given an example of a mixed equation. 2B plus 2CB. How do we work this out? We need to simplify this. So, what do they have in common? They have 2B in common. So let's remove 2B. And when we remove, we leave a bracket. If we take 2B divided by 2B, will give you 1. 2CB divided by 2B leaves C. And that is its simplest form. Our next topic is approximate or rounding off to the nearest numbers. Our rule says always round according to the right digit from the rounding figure. So here we need to know our tens, our hundreds, thousands, and 10,000s. You need to know how many zeros belong to these values. So let's look at our first example, where we approximate the number 546,854 to the nearest hundred. Our focus is on the nearest hundred, and we look at the next number to the right. Because the number to the right is bigger than 5, the number to the left will go up. Nine, So the number has rounded up to 546,900. In our next example, we are asked to approximate 546,854 to the nearest 10. So our focus is the 5, which is the 10. The number to its right is 4. It's less than 5, so it doesn't affect the number to the left. So our answer is 546,850. So this brings us to our final topic, rational and irrational numbers. So let's look at the definitions. Rational numbers are integers which can be put into fraction form. There are 2 rules for these fractions. For example, the fraction a over b. A and b must both be integers. Secondly, b cannot equal to 0. So let's take a look at this number. 3.45165564, and it goes on. There's no sequence in the decimal. 4, 5, 1, 6, 5, 5, no sequence at all. We regard these as an irrational number. On the other hand, in our next example, we have 2.222222, and it goes on. Here we have a sequence, 2, 2, 2, 2, 2, and most likely it will go on, 2, 2, 2, it will recur. This we regard as rational numbers. And remember, folks, any fraction that complies with the two rules is regarded as a rational number. So my name is Curtly Johnson, and I want to thank you for joining me with this unit standard. Keep up the good work. I'll see you next time.